Hello and welcome to this CERN at School screencast, getting started with the MX10. My name's Tom Winty, I'm the Royal Commission for the exhibition of 1851's Schools Research Champion for CERN at School, and I'm here to take you through this brief guide to getting started with your MX10 particle detector. Now you should have your MX10 plugged into your laptop via the USB cable, and it should be set up ready to do the experiment that you want to do. Once you've done that, you're ready to double click on the Pixelman icon that should be on your desktop. This will start the Pixelman software running, and this is used to run the detector, look at the data that you've taken, and then save it for later analysis. So that's what we'll need. When you double click on this, you should see a dark blue box appear. That's the initialization window that will tell you the license information associated with your detector and the software. If you get asked for license information at this point, that means that your detector isn't quite set up correctly, and you'll need to contact the CERN at School team to take you through the troubleshooting guide. But so what we should see is this. We'll just double click here. There's the dark blue box. Langton 6 is my license number that appears, and you should then see the simple preview window of Pixelman. Now, the main feature of this window is this black square here. This is a square that represents the silicon wafer of your detector. It's a 256 by 256 grid of pixels, and each one of those pixels measures the incident radiation that your particle detector has detected. And we refer to this grid as a frame of data. That's one measurement made by the detector. Now, one thing we can do just very quickly is resize this preview window like that, just as you would any other Windows application. But what you'll notice is that the square has distorted into a rectangle. If that happens, you can solve that very easily just by pressing the 1:1 ratio button here, and that will take you back to a square frame so that your data doesn't appear distorted, and that's a good thing. But we'll make this window just a bit bigger, and 1:1, and there we go, we've got our square frame back. Now, before we start actually taking any data, I'll just take you quickly through these three control panels here. We've got acquisition, which controls how the data is taken. We've got picture settings, which is how the data is displayed on the frame. And we've got analysis, which tells you what the software thinks the detector has actually detected. So we'll go through these one by one. We can expand these panels by clicking on the right arrow in the top corner of each one here, and I'll take you through these now. Now, the finite count of steps tick box says to the software, I only want to take a finite number of frames, which is probably a good thing. We want that ticked. Integral mode means that the software would run, if that was ticked, it would run in a way that would sum up all the measurements that were made over all frames, which is useful for things like X-ray measurements, X-ray imaging. But for what we're doing, individual particle measurements, we don't want that ticked, so we leave that as it is. The UXP count, the experiment count, is the number of frames that the software will take, and the UXP time, or the experiment time, is the length of time that each frame will be making a measurement. So here we've got 3 frames, each of 5 seconds. That's 15 seconds worth of data. Not very much in the grand scheme of things, but for this simple demonstration, that's just what we want. And finally, just the panel here telling us that we're in spectrometer mode, which means in principle we can make energy measurements of the particles that we detect. So we can leave all that, close that panel by clicking on the bottom button in the top right, and then go to picture settings. Now this affects how the particles are displayed, and the most important thing about this is the color map. That's the map that takes the values of the pixel energies and maps them to a color that you can then see in the frame above, and that's largely determined by the color map that's used. Now, the thing is, I prefer the hot color map, which goes from black to white through this lovely red, orange, yellow set of colors. But unfortunately, that's not so good for video displays or indeed displaying on a whiteboard. So actually, the best color map to use is Jet, probably. And that takes you from blue all the way to red. And in fact, if you want a lighter blue, there's something you can do with the min level and max level of the picture settings here. So this determines what colors are mapped to the minimum and maximum, and so the 0 is currently this very sort of dark blue here. So actually, here's a little trick. If you set this to say -25, the base level will become this much lighter blue, making it easier to see the different particles. So we'll leave it like that for the moment. A maximum level of 60 should be enough for the type of particles we'll observe now. And then you've got this table of values here, which will tell you properties of the pixels once we've made some measurements. So we'll leave it like that for now. You can hide that panel with the button there. And then finally, this analysis panel is a table of the different particles that are detected. And obviously, we'll need some data before we can see what that's observed. So we'll close that like that. And we should be just about ready to take some data. And we can start doing that by, funnily enough, pressing the lovely shiny start button in the bottom left-hand corner. So I'll do that now. And it's now taking some data. I've got my detector set up with a potassium chloride source. So the potassium-40 in that producing some beta radiation, some electrons through its natural radioactive decay. And you can see those appearing, hopefully, on the screen like this. So it's taken 3 frames of data there, each of 5 seconds. And we can now start to explore that data. The first thing we can do is flick through the different frames that we've seen. So this is frame number 3. This is frame number 2. And this is frame number 1. And this is what I mean about adjusting the minimum and maximum levels to get the best view of the data. So we can change that to 40, for example, and suddenly these particles, these individual clusters that the detector has detected, become a bit clearer. But if that's not clear enough, you can, in fact, zoom in to different particles. So there's a nice one down here. And to zoom in, you click and drag a box over the cluster that you want to have a look at, and you can see here that the pixels then appear much more clearly against this light blue background. And when you hover over the pixels, you can see the properties of the different pixels as the mouse goes over them in this table on the right. And I mean, you can see why I prefer the hot color scheme. If we set this back to how it was, I think there's just something better about the red and the oranges. Anyway, that should be clear, but for the purposes of this video, we'll set it back to how it was. There we go. So yeah, to zoom out again, double click on the frame and you can now see the whole thing. So we can now look at the analysis table and see what types of particles were observed. And in this frame, we've got 4 beta and 1 gamma. Interesting spelling there. And over all 3 frames, there are 14 betas, 1 gamma, and even 1 alpha, which has apparently been identified there. So there we go. That's the data that we've taken. We've had a quick look through it. And now the most important thing to do is actually save that data for later analysis. And we do that by clicking on the File menu at the top left-hand corner and clicking on Save Measurement. This allows us then to create a folder and a file name, a base file name, for the frames of data that we've taken. So I tend to save my data on the desktop, just so it's easy to find later. And we can give that folder a name like Test Data 01. You want to come up with a naming system where you can easily identify the different data that you've taken, but for the purposes of this demonstration, Test Data 01 will do. We can double click on that and then enter a base file name like KCL data, for example. Pixelman will add the .txt extension, which makes it a text file, but there's also another file produced with each frame, the .txt.dsc file, which contains the detector settings. But we can look at those in a bit, so I'll just click save there or press return, and that will have saved the data. And before we close Pixelman, we can check that's all worked by going to the Test Data 01 folder on the desktop, and lo and behold, 3 frames, 6 files that we can now inspect. So if we right click on the .txt file, we can open with Notepad and we'll see the 3 columns representing all of the pixels, the X value of the pixel, the Y value of the pixel, and the energy measured, i.e. the pixel counts. And we can see even there through these adjacent values that you've got pixels that are next to each other in clusters. And you can use Python code or even an Excel spreadsheet to look at these numbers and start plotting them. So that's the payload, the raw data. But accompanying each of those, you've got a detector settings file, which contains all of the detector settings that were used while the detector was running. So you've got things like the acquisition time, that was 5 seconds, all of these detector settings here. And that's handy so that you don't have to write down what the detector settings were at that point. The computer all does it for you, which is very useful indeed. So we've got our data, we've got it saved, we've had a look at it. We're now ready to close Pixelman. So we do that by clicking on this cross in the top right hand corner. It'll say, do you really want to exit the program? All unsaved data will be lost. Well, we've saved our data, that's not a problem, so we can click yes. Pixelman will close, and you can now unplug your detector and shut down your laptop. Now you're ready to start thinking about all the analysis that you can do with the data that you've taken. Okay, well, I've been Tom Winty. That's been this CERN at School screencast, getting started with the MX10. Thank you for listening. I'll see you on the next one. Bye-bye.